In the next coming lectures, I'll be talking about Kubernetes Basics. So all the previous lectures were just an introduction. I just showed you how to set up your cluster and how to run a simple application. Now we're going to go a little bit deeper into detail how to run different kind of workloads on Kubernetes. I am first going to start with an architecture diagram. I'm going to give you a 10,000-foot overview of how the nodes in Kubernetes work. This is the architecture diagram and it has a lot of information. So let's start here with something that you already know. In green, you can see the pods. So we have pod 1, 2, and 3 on node 1 and pod 4, 5, and n on node 2. These are pods like we've started in the introduction. Within those pods, you have the containers. So we had just one container, just like pod 2 and 5 only have one container. So the containers here are denoted in red. You can have multiple containers. If you take a look at pod 3, then you see that pod has 2 containers and pod 1 has 3 containers. Those containers can communicate easily to each other. They can just use the port number, so localhost and a port number, to communicate with each other. If you have 2 small services, let's say one is the backend and one is an authentication service, they can easily communicate with each other. Pods within a cluster can also communicate with each other, but that needs to go over the network. I will show you later on how service discovery works so that pods can easily communicate with each other. Those containers in those pods are running using Docker. So on our nodes, we all have Docker installed. You can also use an alternative container engine, but in our examples, I'm always using Docker. On those nodes, you also have a kubelet and a kube proxy service running. So the kubelet is responsible to launch the pods. So it's going to connect to the master node to get this information. The master node is not shown on this diagram. It's only the nodes that are shown here. The kube proxy is going to feed its information about what pods are on this node to IP tables. And IP tables is the firewall in Linux and can route traffic. So whenever a new pod is launched, then kubeproxy is going to change the IP table rules to make sure that this pod is routable within the cluster. That brings us to the service. And the easiest way to remember how a service works is just to imagine yourself a load balancer. So this can be, for instance, the ELB, the Elastic Load Balancer on AWS. This Elastic Load Balancer on AWS is going to be publicly available. So clients from the internet can connect to this load balancer, and this load balancer is then going to forward the traffic to our Kubernetes cluster. It's going to have all the nodes listed, and the traffic is all going to arrive at IP tables. IP tables has then the rules to forward traffic to another node. For instance, if the pod is running on another node, then it needs to go to this destination node. If the pod is on that node, then it will just forward traffic to the pod and to the specific container in this pod. You have seen that in the AWS example, we have exposed a node port, like a static port. The communication between the service and the node is going over this one port. In AWS's case, the ELB just has one port configured. All the nodes listen to that port, and IP tables will just route the traffic that comes from that port to the correct pod. To translate this to our YAML file, let's have a look how this looks. So we have here a container and we have the pod definition. So when we started our Kubernetes demo, this specification, this spec here, refers to a container, and this container refers to this red block within this pod. The whole green pod is actually the full definition that you see here on the right. The container is just everything you see under spec. If you would have 2 containers, you would just have a spec with 2 containers. In this lecture, I'm going to show you all about scaling pods. If your application is stateless, you can horizontally scale it. Stateless means that your application doesn't have a state. It doesn't write any local files, and it cannot keep any local session data. If you would have 2 pods and one pod is going to write something locally, then those pods would be out of sync. And that means that each pod would have its own state, and that's why you cannot scale it. If both pods would have always the same files, so they wouldn't really have their own state, and if a request to one pod would always lead to the same result as doing the request from the other pod, then the pod is probably stateless. That means that all traditional databases, like MySQL, Postgres, other ones, are stateful. They have database files that cannot be split over multiple instances. Most web applications can be made stateless. Session management needs to be done outside the container. So if you're going to get hits on your web application and you want to keep information of your visitors, then you need to use an outside service. You cannot store that kind of data within your container. You can, for instance, use Memcache or Redis or even a database to store your sessions. Any files that need to be saved cannot be saved locally on the container, because if you stop your container and you start it again, the file is lost. So you need to also save any files that you want to save outside the container, either on some shared storage or on external service. On AWS, this can be, for instance, S3, which is an object storage. Our example app is stateless. If you would run the same app multiple times, it doesn't change state, because in our app, we are actually not running anything. If you have multiple instances of that app, you will just still get hello world. For more information about the best practices, have a look at the 12factorapp.net. This 12factor explains the best practices for stateless applications. Or you can check out my other course, Learn DevOps, Continuously Delivering Better Software, or I have another course on scaling apps on-premise and in the cloud. Both explain those principles. Later in this course, I will explain you how to use volumes to still run stateful apps. Those stateful apps cannot horizontally scale, but you can run them in a single container and vertically scale. To rather scaling apps horizontally, so adding more pods, you're just going to allocate more resources like CPU, memory, and disk to that pod. That is vertically scaling. Scaling in Kubernetes can be done using the Replication Controller. The Replication Controller will ensure a specified number of pod replicas will run at all time. So you just specify, let's say, 5 pod replicas, and then it's going to run the same pod, but then 5 times. A pod created with the Replica Controller will automatically be replaced if they fail, get deleted, or are terminated. If you tell Kubernetes to run 5 pods, and there are only 4 running because one node crashed, for instance, then Kubernetes will launch another instance of that pod on another node. Using the Replication Controller is also recommended if you just want to make sure your one pod is always running, even after reboots. You can then run a Replication Controller with just one replica. This makes sure that the pod is always running, even when a node crashes. To replicate our example app 2 times, we can use this YAML file. So what has been changed? Instead of kind pod, we say kind replication controller. We still have metadata. We have a name, hello world controller. The replication controller also has a spec. In this spec, I'm telling that we're going to have 2 replicas and that this is the replication controller for the app hello world. That's why we have the selector that says app needs to be hello world, which is going to select the label with app hello world. Then we have a template. Here goes our pod definition. The pod definition also has metadata. We have the label, the same one as you saw under the selector, and then we have the pod specification. We still have one container with the name Kubernetes Demo and an image, and we expose port 3000. What the replication controller is going to do in this case is it's just going to run 2 times the pod that is defined in a template. How this works on a Kubernetes cluster, I'm going to show you in the next demo. In this demo, I'm going to show you how to horizontally scale a pod with the replication controller. I just started my Minikube Kubernetes cluster again. So if I type kubectl get nodes, okay, or get node, then I can see Minikube is ready. I have the YAML file in the Kubernetes course, in Replication Controller, Hello World Replication Controller. I'm going to create this. Replication Controller, Hello World Controller created. So let's have a look. kubectl get pods. You can now see that this replication controller created 2 pods. Now we have an Hello World controller dash and then a random string because the name needs to be unique, and then a second one also with unique name. So these ones are now creating. It needs to pull the image again, so they can take some time. So let's describe one of them. So we need to use now this name. Describe pod and then the name. So this uses the replication controller and it's still the same demo. Let's just wait a few seconds now until the image is pulled. Now the image has been pulled and I have the 2 pods running. You can see that now I horizontally scaled my pod. I have multiple instances running. If I have multiple nodes, those instances could be running over multiple nodes, and we could put a service in front of that, a load balancer, that will make these multiple pods accessible to other software or customers. If one of those pods crashes, if one of those underlying nodes crashes, then the controller will automatically reschedule these pods. So let me just remove one of those pods. And then we're going to see that the replication controller is just going to create a new pod. It will see that this pod is gone and it will reschedule a new one. So you can see here now, this pod is terminating and 11 seconds ago, a new pod is already running. The controller will always make sure that the correct amount of pods is running. I can also scale those pods just using the kubectl command. I can do kubectl scale and I can say replicas equals to 4 instead of 2. And I can again pass the YAML file, or I can just specify the full name of this replication controller. I'm just going to show it first with the file name. Replication controller hello world controller scaled. So now you can see it is creating 4 pods because we did the scaling operation. Another way to use kubectl scale is first, let's get the name of the replication controller. We can abbreviate this by RC. This is the hello world controller. And we can say kubectl scale replicas only maybe 1 replica. And then we can say RC / hello world controller. And then it's going to scale it again. So if you do again get pods, you see now 3 of them have been terminated and only 1 of them is now running. Again, to iterate what I said during the theory, this you can only horizontally scale. So this is horizontally scaling. You can only horizontally scale when your pod is stateless. If you have stateful pods, then you will not be able to do this. If you want to know how to create stateless applications, have a look at the 12-factor app. Have a look at my other courses. If you're already sure that you have a stateful application, you will just have to be a little bit more patient because I'll be explaining stateful pods later on in the course. If you want to delete this controller, you can just say kubectl delete rc hello world controller. And then the controller is deleted and the last pod is now terminating. These scaling operations are all saved in Kubernetes itself as a backend etcd, where it saves all those settings like number of replicas. You don't always need to have those in the YAML files. It's easy to have them in YAML files because then you have your state easily available to you in files and you can do testing and you can put those things in version control, but it's not a necessity. In this lecture, I will be talking about deployments in Kubernetes. Let me first talk about the replication set. The replication set is the next generation replication controller. So it's a newer version of the replication controller that I just explained to you in the previous lecture. It supports a new selector that can do selection based on filtering according to a set of values. For instance, the selection could be environment is either going to be dev or QA. Not only based on equality like the replication controller. In the replication controller, you could only say environment equals dev. You couldn't do anything more complex. With the replication set, you can do more complex matching. This replica set, rather than the replication controller, is used by the deployment object. Let's talk about deployments now. A deployment is a declaration in Kubernetes that allows you to do app deployments and updates. When using the deployment object, you define the state of your application. Kubernetes will then make sure the cluster matches your desired state. A state can just be run this application and make sure it is replicated 5 times. It's just the way to describe this to Kubernetes is most easily done now with deployments. That's why just using the replication controller that we saw earlier or the replication set might be cumbersome to deploy apps. So those two things might not be fit to deploy your apps. It would just be too much manual work to then do updates and rollbacks and so on. The deployment object is much easier to use and gives you more possibilities. So what are those possibilities? With a deployment object, you can create a deployment, for instance, just deploying an app, update a deployment, deploying a new version of your app. You can also do rolling updates, which means zero downtime deployments. You're not immediately going to update your whole app, but you're going to do it in steps so that you will have zero downtime during this deployment. You can also easily roll back to a previous version of your app. You can pause and resume a deployment as well. For instance, if you want to roll out to only a certain percentage of your running pods. So this is an example of deployment. It looks, again, very similar to the previous specifications that I showed you. Currently, this is still in V1 beta. That's why you see another API version than V1. For sure, in the next releases, this will become stable and will go to V1. Again, this object has metadata. We give it a name. The name here is hello world-deployment. Then we have the specs. I'm going to run 3 replicas of this pod, and the template is below. Template has, again, metadata. There's a label. The label says app is hello world. The pod specification then, we have 1 container, still our Kubernetes demo, still the same image, and still the same port. So that looks very, very similar to all the other things that we have seen earlier, but I will now show you what the deployments really can do for you. To get information on the current deployments, you can use kubectl get deployments. Because deployments are using replica sets, you can use kubectl get rs, rs stands for replica set, to get the information about the replica sets. kubectl get pods with show labels can show you the pods that are running. You can use pods or just pod, and that will just show you the pods that are running, including the labels. So whenever we add a label to our pod, like the app label, then we can see those if we add show labels. kubectl rollout status and then type deployment and then the name of the deployment object gets the deployment status. So if you want to know whether the deployment was successfully completed, then we can use this command, and this command will show us that. kubectl set image of our deployment hello world deployment, we can change our image from Kubernetes demo to Kubernetes demo with the tag 2. We can actually run another version of this Kubernetes demo. There's a version 2 in this repository that is going to say hello world v2, and if you want to use that newer version of the Kubernetes demo image, then you can just tag your image with the specific version that you want. If you don't use any version, you will use the version tagged to the latest. If you specify one, then that exact version will be retrieved. So using this command can actually update your application to the latest version. You can achieve the same thing using kubectl edit, and then you can edit this deployment object. kubectl rollout status is going to give you the status of the rollout. If you update your image to a new version, then you can use this rollout status to see how the deployment is progressing. kubectl rollout history, if you want to see a history of your deployed versions. So let's say that you first have version 1, then version 2, version 3. kubectl rollout history will show you those different versions. And this brings us to something very useful. If you release a new version of your app, let's say version 3, and you want to go back to version 2, then you can do kubectl rollout undo, and this rolls back to the previous version. If you want to roll back to another version, you can see all the versions using rollout history. If you want to then roll back to version 1, for instance, you can just specify using rollout undo, you can specify to revision and then the revision number. That gives you the possibility to roll back to any version. In the next demo, I'm going to show you how this all works. In this demo, I will show you how deployment works on Kubernetes. In my Kubernetes course from my GitHub repository, I have deployment helloworld.yaml. And this is the file that I showed you during the theory. Now I'm going to create this deployment on my local Kubernetes cluster. Deployment hello world deployment created. Let's try kubectl get deployments. Deployments. I asked for 3 replicas. So my desired state was 3 replicas and the current state is 3 replicas, which means that it already launched these 3 replicas. All the replicas are up to date. They are running the version Kubernetes Demo latest version that I asked to run, and they are also available. So they are running for a minimum amount of seconds, which means I should be able to connect to them. I can also get the replica sets. So this is the replica set that has been created for this deployment. So you don't need to create those replica sets yourself. Kubernetes does it for you. I can also do get pods to see the pods. These are 3 pods. And I can also say show labels. And then you see the label. So I said that my label should be app hello world. So you see here app hello world is the label for this pod. It also has a pod template hash, which is automatically generated. I can also ask the rollout status of this deployment, hello world deployment, and it is successfully rolled out. We didn't really need to enter this command because we could have seen this information using the get deployments. But this is just another way to see if our app is deployed. If I log in to hubdocker.com, then I also pushed earlier a newer version with tag number 2. So not with tag latest, which is automatically added if you don't specify a tag, but with tag number 2. This is a different version and it is going to say hello world v2 when I would launch this app. So what I'm going to show you is how to change the version of this first version to version 2 and then back to the old version. Let's first check what the app would give back if you would connect to it right now. To do this, we have to run kubectl expose again. We're going to expose a deployment, and the deployment is going to be the hello world deployment. And the type is going to be a node port. Like we want a static port automatically assigned that we can connect to. This expose command created a service for us. So let's do get service. And now we can see that there has been a service created. So let's describe this service. Hello world deployment. So we see that port 31969 has been opened as a node port for this service so we can connect to our app. Minikube service hello world deployment URL is going to give us the URL of our Minikube cluster it's going to be the IP that we can use and the port that has been exposed here. The internal IP addresses of Kubernetes are different than the external IP address that we can connect to. So we're going to go to this URL. I'm going to use curl. It gives us hello world. So let's now change this version. So what I'm going to do now, I'm going to set a new image. I'm going to do kubectl set image of deployment / hello world deployment, and my image, I'm going to change my Kubernetes demo image into my new Kubernetes demo version 2. So we're going to change the Kubernetes demo that was tagged with latest because we didn't provide a tag. So it's going to be latest with the tag number 2. And this now says image updated. We can now follow this rollout status using this command, and it is already successfully rolled out. So if we then curl again to this URL, we see hello world v2. So our image is now updated, and it actually updated all our running pods because we have multiple pods running. So you see 3 of them have been terminated, 3 of them have been started again with this v2 version. Let's say that I want to see the history, kubectl rollout history. So I see revision 1 and revision 2. You don't see any change cause because when we did the kubectl create -f of this, we could have added record, and this record would then also show changes right here. Haven't used this, so that's the reason why it shows none. So we're not really happy with this version 2. I rather want to see hello world without the 2. So let's undo this deployment. So I'm going to do kubectl rollout undo and then the name of our deployment. So now it's rolling back. Successfully rolled out again. It goes very quick because those images are still on file. Again, 3 new containers, and then if I curl, it's back to hello world. So this way you can easily change your versions from one application version to another application version and very quickly do rollbacks if necessary. Let's say that I want to go back to another revision, and the revision is already a long time ago. That's also possible, but by default it only keeps 2 revisions. So we would have to edit, kubectl edit can do that, our deployment object, and we would have to change this limit parameter. So this is our object. We can just make some changes here. And the change that I'm going to make is I'm going to set a revision history limit of 100. I edited this, and now let's do another rollout. Let's go back to number 2. Let's check our history again. And now that we made a few changes, you can see that our history is getting longer. So here I have my 3 revisions, and then if I want to go to another revision, I can say to revision number 3, for instance. And then it is actually rolling back to revision 3, which becomes a new revision because now I'm at 6. Using the undo and to revision can just let you jump to any revision that you want. And I have no idea anymore on what version we are, but we are back on the original version. Deployment objects are the objects that you want to create when you are deploying your applications. You can also use a replica set or the replication controller, but those are just too abstract. Deployment is going to be the way that you want to put your app on Kubernetes. And then you can manage the lifecycle of your app much better using the rollbacks and the rollouts and so on. In the next couple of lectures, we will see some more details about the labels and about health checks, and also how health checks can then improve the resiliency of your app. In this lecture, I'll be talking a little bit more about services. Pods are very dynamic. They come and go on the Kubernetes cluster. When using a replication controller, pods are terminated and created during scaling operations. When using deployments, when updating the image version for instance, pods are terminated and new pods take the place of older pods. That's why pods should never be accessed directly, but always through a service. A service is the logical bridge between the mortal pods and other services or end users. When using the kubectl expose command earlier, you created a new service for your pods, so that it could be accessed externally. Creating a new service will create an endpoint for your pods. You can either use a cluster IP, which is a virtual IP only reachable from within the cluster. This is the default. Or you can use a node port, and that is a port that is the same on each node that is also reachable externally. If you want to reach your pods externally, this is what you need. Or you can go for a load balancer, and this is used for production applications on the cloud. A load balancer is created by the cloud provider that will route external traffic to every node on the node port. I showed you how this works. I did that using ELB, Elastic Load Balancer, on AWS. The options that I just showed you only allow you to create virtual IPs or ports. There is also a possibility to use DNS names. If you use external name in the service definition, you can provide a DNS name for the service. For instance, for service discovery using DNS. This only works when the DNS add-on is enabled. I will discuss this later in a separate lecture. I'm going to talk about service discovery, and I will then talk also about this DNS add-on. This is an example of a service definition. You could also create the same service using kubectl expose. It does the same thing. It has API version 1. The kind is service. It has a name. The name is Hello World Service. And in the specification, we're going to define the port. So the port that we're going to use is 31001, and it's going to be a node port. So you see at the bottom here, this service is of type node port. The target port is a Node.js port. So this name Node.js port I defined in my pod, and this is port 3000. The protocol is TCP, and the selector is app hello world. So this will be the service for the pod that has the label app hello world. You don't have to specify this node port. If you don't specify it, then it will be a random port. If you specify it, then this port will be used, but this service can only be created if this port is still available. So you will have to manage port collisions yourself. Also note that by default, services can only run between ports 30,000 and 32,767. But you could change this behavior by adding the service node port range argument to the Kube API server. Kube API server is a process that starts, so in the init scripts of your master node, you could change this service node port range if you would want another range for ports. You would then have to make sure that you don't have collisions with ports that are already used on the node. Typically, this is already a good setting. What you're going to do is, if let's say you want to use a default HTTP port, then you're just going to put an AWS load balancer in front of it. In the next demo, I'm going to create this service of type node port. In this short demo, I'm going to show you how to create a new service from a YAML file using a static port. I still have my Minikube running. I don't have any pods, so I'm going to create another pod again. So I'm going to do kubectl create. From my first app, I'm going to create this hello world. So this is the hello world pod, helloworldexample.com. I'm going to describe it again. So this has started. So it has the label app hello world. For this pod, I'm going to run a service. So I have first app hello world node port service. And this is going to open the node port 31001. It's going to use the Node.js port, which is defined right here in the pod definition, there's name Node.js port. This pod has labels app hello world. I have a selector on app hello world. So this is going to be the service for this pod. And I'm specifying this node port. So rather than having a random port, I should be able to access this port, and then I will be able to connect to this pod. So kubectl create this first app hello world node port service. And then for Minikube service, the name of this service is in the metadata, hello world service. I want to know the URL, and you see it has port 31001. This is the IP I can use to connect to the app. So I'm going to do curl of this URL, and I get hello world. Now, if you're on AWS, then you cannot do this command, but you can go straight to the nodes. You just have to change the security groups. I already showed you this in one of the introduction lectures for AWS, how you can do that. This is just showing how you can do the same thing, creating a service, but with a static node port. If we ask the info from our service, we can do kubectl describe, and you can either say service or you can say SVC, which is short for service, and then we can describe this hello world service. And this will give us some more information. If we want to get a list of all the services, we can just do kubectl get SVC, and then we get a summarize of all running services. This was already here. It's one of the services running for Minikube. This is the one we created. So you see here cluster IP. This is the IP here. This is the cluster IP I was talking about in the theory. This is the default cluster IP. This is the default virtual IP that our service gets. This IP is only reachable within the cluster. This is the IP that we can use to externally access the cluster. And then we see node port 31001. We also see that another endpoint has been created. So this endpoint can also be used within the cluster. So there are multiple ways to access your app. This node port is going to be the static way to access our cluster. Let me delete this service and let me then create it again. Let's describe it again. You see IP address is now different. So this virtual IP changes if we don't define it in the YAML file. So this one for us is not static. This port number, because we defined it, is a static port number. This is the one that we can use to configure external services to access our application in this pod. If you would want a static virtual IP, a static cluster IP, we would also have to define this in our YAML file. That's it for this demo. I will come back to services when I'm going to discuss service discovery using DNS. In this lecture, I'll be talking about labels. You've already used labels, but in this lecture, I want to show you some more possibilities. Labels are key value pairs that can be attached to objects. Labels are like tags in AWS or other cloud providers, used to tag resources. If you've been using cloud, then tags will be very familiar to you. Labels are kind of the same thing. You can label your objects, for instance your pod, following an organizational structure. You can say I want to tag my pods using key environment and value, either dev, staging, QA, or prod. And then you know whether your pod is part of your development environment or any other environment. You can also add another tag. You maybe have multiple departments, so you could say I'm going to tag all my pods and I'm going to say this is going to be from engineering, these pods are running software for finance, or these pods are running software for marketing. In our previous examples, I have already been using labels to tag pods. This is how it looks. I always added labels, for instance, the app hello world. Labels are not unique and multiple labels can be added to one object. Once labels are attached to an object, you can use filters to narrow down the results. This is called the label selectors. Using label selectors, you can use matching expressions to match the labels. For instance, a particular pod can only run on a node labeled with environment equals development. More complex matching is also possible. You can say environment needs to be either development or QA. In earlier lectures, I have been using node labels for the services. The services had a label selector to select the correct pod that the service was going to be for. You can also use labels to tag nodes. Once nodes are tagged, you can use the label selector to let pods only run on specific nodes. There are 2 steps required to run a pod on a specific set of nodes. First, you tag the node itself, then you add the node selector to your pod configuration. It can be to a single pod or a pod template within, for instance, a deployment. The first step is to add a label or multiple labels to your nodes, and you can do that using kubectl label nodes. You just specify the node name and then the label that you want to give it using key equals value. Secondly, you add a pod that uses those labels. Here we have a pod definition, and we just added the node selector. This node selector says hardware needs to be high spec. This pod will only run on nodes that have the label high spec. I will show you how this works using a deployment with a node selector in the next demo. In this demo, I am going to show you how to use the node selector using labels. I'm going to show you how this works using Minikube, because not everyone has an AWS cluster, but it really makes sense only if you have multiple nodes. So our Minikube only has 1 node, but I can still show you how it works. I have in my deployments folder, I have a hello world with a node selector. So let's see what's in here. It's a normal pod specification here, but we have the node selector, so it can only run on the hardware high spec. I'm going to first show you the labels of our nodes. So here you can see the labels. So we don't really have the label hardware high spec. What is then going to happen when we try to start this one? I will show it to you. kubectl create of this hello world deployment. Let's have a look. We have 3 desired, 3 running, 3 up to date, but 0 available. Let's have a look at our pods. It's all pending. So let's have a look at one of the pods. kubectl describe pod. And it says failed to fit in any node. This pod is trying to run on one of the nodes and needs to match the node selector. And then matching was, of course, using this hardware high spec. But there's no hardware high spec key value available on any of our nodes. So first we need to add the label. And I can do that using kubectl label nodes. The name of this node was Minikube, and I want hardware equals high spec as a label. So node Minikube labeled. Let's do a get nodes again with show labels. And what does it say now? Hardware equals high spec. So now we just have to wait a little bit, because the node needs to figure out that this node now has a label. And you can see in our case, it didn't need a lot of time. It is now running. So if you do describe pod, and then let's take this pod, we see in the beginning we had a warning. We couldn't schedule the pod, it was not running, but once we changed the label, it could actually run on this node. If you have multiple nodes, you can specify this label on certain nodes, and your pods will only then be scheduled on these nodes. Very useful if you have different types of hardware. If you want to make sure that a certain workload only runs on a certain type of cluster, then you can use this. So that's it for this demo. You can try it out yourself using Minikube or even on the AWS cluster. In this lecture, I'm going to be explaining health checks. When you put your app in production, you will definitely want to configure health checks. If your application malfunctions, the pod and container can still be running, but the application might not work anymore. The app gives an error because of something internally that went wrong. To detect and resolve problems with your application, you can run health checks. You can run two different types of health checks. The first one is running a command in the container periodically. You're just going to execute a command within the container to check whether your container is still working. The other one, and the one that is used most of the time, is periodic checks on a URL using HTTP. Your app probably is going to expose an interface. Using periodic checks on that interface, you can check whether your app is still healthy. The typical production application behind the load balancer should always have health checks implemented in some way to ensure availability and resiliency of the application. Even if you're using AWS and the load balancer, the health checks are not checking whether your pod is healthy. It is only checking whether the node port is accessible. So even when you're using the AWS load balancer, you're going to want these types of health checks as well. This is how a health check looks like on our example container. Here again I have the pod, the example pod, and here is then in bold the health check. It's a liveness probe using an HTTP GET on just slash, which means just the main website. On a production application, you're probably going to have something like /health, but here I don't have a separate health page, so I'm just using slash. The port is going to be port 3000, which is the container port, or if you give your container port a name, then you can just use that name. There's an initial delay in seconds, so the liveness probe is going to wait 15 seconds, and there's a timeout of 30 seconds. How this exactly works, I will show you in the next demo. In this demo, I'm going to show you how to add a health check to your deployment. In your deployments folder, you will find hello world healthcheck.yaml. This is our deployment object. Still has the Kubernetes demo as a container, but here we add the liveness probe. And this liveness probe is going to check / on the Node.js port, which is port 3000. And it will wait 15 seconds before doing the first check. And we have a timeout of 30 seconds. We can just do kubectl create and then using kubectl get deployments or get pods, we can get the status of one pod. Describe pod. And in the details, we see there's a liveness HTTP GET on this Node.js port with a delay of 15 seconds, a timeout of 30 seconds, with a delay between the checks of 10 seconds. The pod will consider it healthy when there's one success or unhealthy when there's 3 failures. So then we have 3 pods running on our node, and if one of those pods gives an error, so at that point the container is still running, this container is still running, Node.js is still running, but for some reason our app crashed, doesn't work anymore, doesn't give an HTTP 200 code anymore, which is the normal code, but for instance code 500, which shows that there is something wrong, then what Kubernetes will do is it will terminate the pod and launch a new pod. And this is very important because if the pod is not working anymore and you route traffic to it, then the end user might get an error while there are still other pods that might be healthy. So what you want is that you don't route traffic at all to pods that are not healthy. And that's why we have this health check. So this health check is very useful and you should always include it if you're deploying applications in production. If you want to edit any settings right now of this deployment, you can use kubectl edit. And here you see the settings that you can change. So this is a useful trick to also see what settings are available, like the timeout, like the period, the success threshold, and the failure threshold. So these you can either edit right here or include them in the YAML file if you would want to change them. Otherwise, the default values will be used. The Readiness Probe. Besides liveness probes, you can also use the readiness probes on a container within a pod. Liveness probes indicates whether a container is running. If the check fails, the container will be restarted. Readiness probes, on the other hand, indicates whether the container is ready to serve requests. If the check fails, the container will not be restarted, but the pod IP address will be removed from the service, so it will not serve any requests anymore. The readiness test will make sure that at startup, the pod will only receive traffic when the test succeeds. You can use these probes in conjunction and you can configure different tests for them. If your container always exits when something goes wrong, you don't really need the liveness probe. But in general, you configure both the liveness probe and the readiness probe. In this demo, I'm going to show you the difference between the liveness probe and the readiness probe. In the previous lecture, I showed you how to use the liveness probe. Let's have a look at this script again. Hello world health check. Here we have the liveness probe defined, an HTTP GET on / within the app. Let's have a look between the difference of this check and the other check. If you do kubectl create of hello world health check, and immediately afterwards we do a watch of the pods, kubectl get pods, then you will see that the pod is immediately ready. So it's now running and it became immediately ready. It didn't wait for any check to perform. So that means it's immediately serving requests. The readiness probe is different from the liveness probe because it will first wait until the readiness probe succeeds and only then it will start serving requests. Let's have a look at the hello world liveness readiness YAML. Here I have also a readiness probe. Works exactly in the same way as the liveness probe. To define it in the YAML file, you can also use the HTTP GET. But the difference is when we do a create of this one and then we do a watch, you will see now the container is creating. Now it is running, but it's not ready yet. First, this initial delay needs to pass, then the check will be executed once, and only when the check is executed and it came back successful, then the pod will be ready and it will be ready to serve requests. Only now it is ready. So that's the difference between the liveness and the readiness probe. So let me show you again this file. So here we have the initial delay seconds, 15 seconds, and then the readiness probe started checking, and only then when it had a success back, then the pod was ready and the pod IP is added to the service and the service will redirect traffic to that pod. If the readiness probe fails for some reason, then the IP address will also be removed from the service and no traffic will reach this pod until the readiness probe gives a success again. If you use this in combination with the liveness probe and we use the same path, then what's going to happen is it will be removed from the service and the container will be restarted to make sure that the container works again. And the container will be restarted because that's what the liveness probe does. If the probe fails, it will restart the container. So that's it for the liveness and the readiness probe. Let's talk about pod state. In this lecture, I'll walk you through the different statuses and states of a pod and a container. I will talk about the pod status field, which gives you a high-level status, the pod condition, which is the condition of the pod, and the container state, the state of the containers itself. I will then show you the lifecycle of a pod in the next lecture. Pods have a status field, which you see when you do kubectl get pods. Here you see the status field. In this scenario, all pods are in the running status. This means that the pod has been bound to a node, all containers have been created, and at least one container is still running or is starting or restarting. Other valid statuses are pending, the pod has been accepted but is not running. This happens when the container image is still downloading, so if you have a slow network connection, this can actually take some time. If the pod cannot be scheduled because of resource constraints, it will also be in the status. So let's say that you don't have enough CPU or memory anymore, then this pod will stay in pending status and you will have to investigate, for example, using kubectl describe to see the events to know why exactly the pod is not scheduled. Succeeded, all containers within this pod have been terminated successfully and will not be restarted. Failed, all containers within this pod have been terminated and at least one container returned a failure code. The failure code is the exit code of the process when a container terminates. So exit code 0 means OK, and all other exit codes are a failure. Also, you can have unknown, the state of the pod couldn't be determined. A network error might have been occurred, for example, the node where the pod is running on is down. So these are the pod statuses. You can get the pod conditions using kubectl describe pod and the name of the pod. So here we do a kubectl describe of a pod of the API server in the namespace kube system. These pod conditions are conditions which the pod has passed. In this example, initialized, ready, and pod scheduled. There are 5 different types of pod conditions. Pod scheduled, the pod has been scheduled to a node. Ready, pod can serve requests and is going to be added to matching services. Initialized, the initialization containers have been started successfully. I will talk about these initialization containers in the next lecture when we go over the lifecycle. Unschedulable, the pod cannot be scheduled, for example, due to resource constraints. And containers ready, all containers in the pod are ready. There is also a container state. You can get the container state using kubectl get pod, outputting using YAML so that you can see all the data that is available for the pod. And here you have the container statuses. You have some information about your container, and then here in bold you have the state, and the state of this container is running. So this comes from Docker itself, so Docker reports that this container is running. The container state can be running, terminated, or waiting. In this lecture, I want to show you the pod lifecycle. This is a diagram that I created to give you a better idea of what really happens when you launch a pod. This diagram also shows you the init container that you can use, the post start hook, and the pre-stop hook. Those you can define in your YAML file, in your pod specification, to execute commands at certain points in the lifecycle of the pod. Let's start with the init container. When you define an init container in your pod specification, you can launch a new container that is separate from the main container that will execute some commands. This can be interesting if you have volumes, for example, to do some work on those volumes, set some permissions, create some directories before the main container starts. So this is a completely separate container, and the main container will only start after this init container is completed. Then we have the post start hook, and the post start hook starts at the same time as the main container if you define it in your container definition, and it starts within the main container, so you can just execute some commands within the main container. Again, if you need to do some work, just when the container starts. Then we have the pre-stop hook, and that one is going to be executed when the container stops. So here, again, if you have to do some work, when the container stops, then you can use a pre-stop hook. We have the main container, and within the main container, we can also define the Readiness Probe and the Liveness Probe. These Readiness Probes and Liveness Probes will only start after the initial delay seconds that you define as well in your probes. So the moment that your main container starts, this initial delay seconds will delay the Readiness Probe and the Liveness Probe, because often your app needs some time to start, to connect to a database, and it doesn't make sense to immediately start a probe, but often it only makes sense after a couple of seconds to then start checking whether the app is working. So this is the pod lifecycle. Now let's go over the different states. When the container is running the init container, then you will see in the describe, if you go and take a look at the conditions, that initialized is still false, ready is still false, but the pod is scheduled. So the pod is scheduled, the init container is running, it means that initialized is false. Then after the post start hook is executed, initialized will be true, it will still not be ready, and the pod scheduled is still true. The reason why it's not ready is because the readiness probe hasn't executed. So if we have a readiness probe, only after the readiness probe returns success, then we have initialized true, ready true, and then the pod is scheduled. And then the pod is live, it will be added to the service and traffic will be routed to this pod. In the next demo, I will launch a container that has all these elements in it so that you can see them being executed. I'm going to show you a demo of the pod lifecycle. I am in the directory pod lifecycle in the Kubernetes course, and here I have a lifecycle YAML file. This is a deployment, and in the pod specification, I have an init container. So this is the first container that is going to be executed. This is a separate container, just like I showed you in the previous lecture. So we also define an image and a command that will be executed. This container is just going to sleep 10 seconds and then exit. Then we have our main container, the lifecycle container, also image busybox, and it's going to write to a file the date, and it's going to say it's running. So the file is /timing, then we're going to echo the app is running, and then we're going to sleep for 120 seconds. We have a readiness probe. This is also going to write to this /timing file so that we have a nice overview of the timings. The liveness probe, the lifecycle, and in the lifecycle we have a post start and a pre-stop. So these are the hooks that we're going to use, and using those hooks we can execute a command in our main container. So here we're also going to write to /timing just to see when this command will execute. And then the pre-stop is also going to write to our file and then is going to sleep for 10 seconds. In the init container is not going to write because that is a separate container, so we would not get that information anyways. We would have to use a volume to share information between the init container and the main containers. So let's run this, and I'm going to show you this in a split screen. So I'm going to use a tool called screen, and I'm going to split my screen. Here at the top, I'm going to run watch and one kubectl get pods. There are no pods currently. And then here in this other screen, I'll create a pod. And then I will also read this timings file. kubectl create -f of this lifecycle YAML file. I will press enter, lifecycle created. And now we can already see that it's running the init container. So the init container, which runs first. Let me kubectl execute -it. You see now that the pod is initializing. So I will do cat timings or timing. And we already have the main pod running. So first we have running, that is the main container. Then we have post start and then end post start 10 seconds later. And now the readiness probe. So let me tail this instead. Tail timing -f. It's going to be easier. So the main container started. Now that says running. Then we have the post start that starts. So these two start together. The main container and the hook, the post start hook, start together. It takes 10 seconds. And then we have the end post start. And then after the initial delay, we have the readiness probe and the liveness probe. So those will execute both of them will execute as long as the main container is alive. The main container will be alive for 120 seconds. So we still have status running, which means it's still alive. We still see the liveness and the readiness probe. Just have to wait. I will just pause the video for a second and wait until the container stops. And now the container is completed. And then the command is terminated with exit code 137. So the pod has been terminated and the stop hook is also executed, but you don't see it anymore because the sleep command has been terminated. The pod is again running because remember, the liveness check will restart the container when the probe fails. So in this case, the probe failed because the command has been terminated. What's going to happen then is that the liveness probe is going to restart container. The readiness probe will make sure that the container is not in ready status, so that there's no traffic sent to the container. And when the container is started, the readiness and the liveness probe will do their checks again. And when the readiness probe succeeds, the IP address of the pod will be again added to the service and the pod will start serving traffic again. So you can use this file and execute this on your own system to see how this works. These init container and the hooks are very useful to use to execute commands at certain times of your pod lifecycle. In this lecture, I'll be talking about secrets. Secrets provides a way in Kubernetes to distribute credentials, keys, passwords, or secret data to the pods. Even Kubernetes itself uses this secrets mechanism to provide the credentials to access the internal API. That means that pods have access to secrets, and those secrets must be distributed using this secrets mechanism. In the demo, I will show you exactly how it looks like. You can also use the same mechanism to provide secrets to your application. If you have an application that needs credentials, you can use this same mechanism. Secrets could be, for instance, a database login and password, or anything that needs to be kept secret. Secrets is one way to provide secrets, native to Kubernetes. There are still other ways your container can get its secrets if you don't want to use the secrets in Kubernetes. For instance, you could be using an external vault service in your app. There are external vault services that you can use that your app might be contacting. So you can write that completely in the app layer. You don't really need Kubernetes for that. I'll be explaining this native Kubernetes secrets in the next coming slides. Secrets can be used in the following ways. You can use secrets as environment variables. So in your application, you will just have to read the environment variables, and that's where the app will then find the secrets. You can also use secrets as a file in a pod. This setup uses volumes to be mounted in a container. In this volume, you have files. So in your container, you're going to have a volume. It means it's just a directory that your app can access that contains then those secrets. It can be used, for instance, for .env files, if you are familiar with those, or your app can just read this file or these files. So your app, you can just write some code that says you need to go and look in the specific directory for the secrets that you need, for instance, to connect to a database. You can also use an external image to pull the secrets. Obviously, from a private image registry, you cannot put your secrets in a public image registry. In that case, it would mean that you will have a second Docker image and that image would be pulled and your app would then read the data that contains the secrets from that image. First, you need to generate the secrets. So you have a login and password and you need to put that in Kubernetes. To generate secrets using files, you can use these commands. So first, we're going to create those files. If you don't have them already, you're just going to create a file username.txt. I'm going to put root in that file and we're going to create a file password.txt and we are going to put the string password in that file. Then you can say kubectl or kubecontrol, create secret generic. It's a generic secret. You give it a name and you say from file username.txt and from file password.txt, and then you have the secret database user pass that has been created that you then later on can use. A secret can also be an SSH key or an SSL certificate. Here you say kubectl create secret generic, you give it a name again, SSL certificate, and the from file is a key rather than a username or a password. So that's a way to distribute keys, for instance. If you want to generate secrets using the YAML definitions, previously we always used the YAML files, you're going to create a file secrets.db secret.yaml, and this definition is going to be of kind secret. You're going to give it a name, a type, and then you're going to supply the data. Here you're going to supply base64 strings. On the right, you see how you can generate those base64 strings. So you need a Linux or Mac machine, or you can search online for a base64 generation tool. You say, I have the string root, or you have the string password, and you generate a base64 string for that. Then you use that in your YAML file. After creating the YAML file, you can just use kubectl to create the database secret. Once the secrets are created, then you can use them. At that point, you have the three options. I will show you the two most common ones, which is the files and environment variables. If you're going to use environment variables, you can create a pod that exposes the secrets as an environment variables. Here we have the pod definition that we always have been using. And what you're going to do is you're going to add env, you're going to give your environment variable a name, and then you're going to say that you want to have the value from another source. The source is going to be the secrets, and you're going to say that the name in the secret is database secret, and the key that you want is username. Database secret is the name of the object in Kubernetes. The key is username. The value will be then the secret value that you stored in Kubernetes. You can do the same with other environment variables that you want to have in your pod. Alternatively, you can provide the secrets in a file. Here we have a volume mount. Within our container that you want a volume. Volume mount, we give it a name, we give it a path. So this is the path that your app will have to use. It's etc creds. Read-only true, your app that is running in this container cannot change this, can only read this. And then we're going to have a volume definition. And in this volume definition, you're also going to define a name, cred volume. So this name, cred volume, must be equal to the volume mount, because in the volume mount, you're referring to a volume here that you're creating. This volume exists of secrets. So you're going to say secret with a secret name, database secrets. So all the keys and values of database secrets will now be inserted, will now be put in this etc creds folder, and the secrets will be stored in etc creds, database secrets, the name of the secret, and then the keys. You have the key username and password, so you will have two files, username and password, that the application can then read. The only thing that the application needs to do is read those files, and it can then use the secrets within the application. Using volumes and using environment variables, using these two ways, I will show you in the next demo. I am going to show you two demos using secrets. One demo will just be my very simple example app. And in another demo, I'm going to show you how to set up a WordPress using secrets as environment variables. Let's first start with the first one, secrets as volumes. I first need to set up the secrets. In my deployment, I have hello world secrets.yaml. This hello world secrets has the username and the password. Kube control create of this file deployment hello world secrets.yaml. And then I have another deployment. I have a hello world with secrets as volumes. 3 replicas of this one, 1 container, a volume mount, and this is the volume with the secret name db secrets, the one I just created in Kubernetes. And this will be mounted under etc creds. kubectl create again. And then let me just get the pods. All of them are running. Let me describe one of them. Describe pod. And what I want to show you first is what I mentioned in the beginning, that Kubernetes itself also uses the secrets in volumes to share the Kubernetes credentials. And that you can see here, volume mounts, we already have a volume, var run secrets Kubernetes service account from default token. This is a volume that is already mounted and is done by Kubernetes itself to share the secrets within the pod, so the pod can access the API. And then we have the ET secrets, the one that we created from the cred volume. So let's start a shell, kubectl, execute the pod name. We're going to execute something on the pod. I'm going to add some flags to enable standard input that we can actually type in some commands. And then we're going to execute /bin/bash, which is a shell. And this just gives us a shell on one of the pods. If you then take a look at what's in etc creds username, then you see root is in username and password is in password. So our credentials are available in this etc creds, and your application just has to read those files, and then those values, the data in those files, can be used, for instance, to connect to a database. And that's exactly what I'm going to show you in the next demo. I'm going to show you how to use credentials to spin up a database and WordPress. If you enter mount, then you can also see all the mount points, and here are the two volumes that are mounted. So this one is the default one. If you can have a look at it, it has a token and a certificate that can be used then to access the API. Exit if you want to exit from a shell, and then you're ready for the next demo. In this demo, I will show you how to set up a WordPress using the secrets. It's not a fully working WordPress yet. The more features of Kubernetes you will see, the more I will change the setup a little bit. And at the end of the course, you will actually have a WordPress that is working. We don't know how to use stateful containers yet. That's why whenever you're going to put data in this WordPress, it's not going to be persistent. Whenever your pod shuts down, the data is gone. But that doesn't stop me of showing you already what we can do now using those secrets. So the WordPress files are in a directory called WordPress in my GitHub repository of the Kubernetes course. The first file I want to show you is the WordPress secrets. This WordPress secrets has one secret, a database password. You can change the database password into something more secure, but this is just password. Then we are going to need a deployment. So I have a file called single deployment, no volumes, because we're not using any volumes to persist data yet. That's why I called it that way. It only has one replica. It's just one deployment of our app WordPress. This deployment has two containers. WordPress is a blog software, in case you didn't know yet. This has a container that is referring to the image WordPress version 4 with PHP 7. This container is one of the official WordPress images, and it comes with PHP and Apache, which is the web server. So it's a website, it's blog software, all bundled within one image, and that's what we're going to pull from the Docker repository. It's going to expose port 80, and we need to provide some of the environment variables. We need to provide a password of the database, and that's why we're going to use this WordPress DB password. And if you're wondering why I know this name of this environment variable, this is all explained on the website hubdocker.com of WordPress, and I will just show you that. This is the official repository for WordPress. It's a rich content management system and can utilize plugins, widgets, and themes. And then here you have how to use this image. And then you can see we have a WordPress DB host, WordPress DB user, which is root, that we're not going to change because root is fine for us, and then a password, which we are going to set. You can also change the database name, the table prefix. You can set some other settings like an authentication key and so on. But if you don't set those, then it will be auto-generated, which is fine for us for now. You also have different images. We are going to use the one with PHP 7 and Apache, but you can also use the one without Apache. You can put an Nginx in front of it if you want, but that would make it a little bit more complicated. So we're just going to keep it relatively simple for now. So that's how I found out about this WordPress database passwords. And the value for this key, for this environment variable, is going to come from the WordPress secrets. And I'm going to use the database password for this. The next environment variable that I'm going to define is the WordPress database host. And I'm going to use 127.0.0.1, which is basically localhost. Because this is going to refer to another container, the second container that I have in this spot. I have a MySQL container, which is a database. MySQL version is 5.7. This is also an official image from Docker Hub. So you can also take a look at Docker Hub to read the instructions. It exposes the standard MySQL port 3306, and we're also going to define an environment variable with the MySQL root password. And this MySQL root password is going to have the same value as this one, which is the password that comes from our WordPress secrets. So the password needs to be the same because our database will be set up with this password. The login will always be root. And we also want to let our application know that it can log in using the same password. You can set some more environment variables, but this will do. We have one pod, 2 containers, and only 1 replica. Because if you would increase this to 2, we're going to run 2 databases and it's not going to make sense. We only want 1 database and 1 WordPress in front of it. So let's launch this one. Kube control create -f of the secrets. Secrets first, WordPress secret. Secrets created. And then now we can create the deployment. WordPress deployment created. So let's have a look at the pods. I still have my hello world from the previous demo. And then here I have the WordPress deployment running. 2 containers this time. kubectl get or describe pod. And here we have the 2 containers running using our secret. To reach this WordPress, I need to make a service. So I also have a WordPress service that is going to target my HTTP port for my pod. It's the service for the app WordPress, and is going to expose this port as a node port. So type node port. Kube control create -f, and then minikube service WordPress service, and then URL. And then I should be able to access our WordPress. I'm going to do this in a web browser. And then here we have our WordPress. So we just need to do some setup. This is going to be my blog, my username. I can use this password. My email address. You can discourage search engines from indexing this website. It's not even online, it's just on my PC. And then you can say install. And then it is installed. It goes very quick. And then you can log in. So I can now log in. And then welcome to WordPress. So I have my dashboard. It's all working. And then if I click on visit website, I can actually visit my blog website. So it was that simple to set up a blog. But it's not fully working yet. Because this container is still going to write some data to the local image. If I'm going to upload media, like images, then those images will be written on the container. If that container restarts, all my images will be gone. So we'll have to find a solution for that. And I will show you what happens when the pod gets killed. Kube control get pods. So let's say that our pod gets killed. kubectl, I'm just going to delete my pod, which will be launched again by the deployment. So my pod is deleted and a new pod is launched. But what's going to happen now? Because we launched a MySQL that contains all the data, the installation that we have done now, my login and password that I filled out. But like I said earlier, those images, they boot up. You can write some data to that image, but when you restart a pod, it's nowhere saved because there are no data mounts, there are no volumes that we are using yet to keep the data saved somewhere. It's just if a container restarts, the data will just be gone. So what then happens if our pod gets rescheduled or is killed? Well, I will just refresh this page and all the data is gone and I can just reinstall WordPress because my database is completely wiped. It is reinstalled because the data was not saved. This is still something that we have to find a solution for, and I will explain the solution in the volumes lecture later on. But for now, it's already a very interesting lab because this already touches a lot of things. We had a deployment, a service, secrets, environment variables, and multiple images in our pod. Let's talk about the WebUI. Kubernetes comes with a WebUI you can use instead of the kube control commands. You can use it to get an overview of running applications on your cluster and for creating and modifying individual Kubernetes resources and workloads, like kube control create and delete. Retrieve information on the state of resources, like when you use the describe pod command or describe deployment. In general, you can access the Kubernetes WebUI at the Kubernetes master URL/UI. If you cannot access it, for instance, if it's not enabled on your deploy type, you can install it manually using kube control create, and then you can use the YAML file straight from the Kubernetes repository. If a password is asked, you can retrieve the password by entering kube control config view. If you're using Minikube, you can use the following command to launch a dashboard. Minikube dashboard is going to open your browser and will go straight to the URL. If you just want to know the URL, you can use Minikube dashboard --URL and then you can copy paste it yourself in the browser that you want. In the next demo, I will briefly show you around the WebUI. In this demo, I will show you how to add the WebUI in Kops. In my Vagrant Kubernetes course, my Git repository, I have a directory dashboard. In this dashboard, I have a README that you can use to start your dashboard on Kops. In earlier releases of Kops, it was pretty easy to start a dashboard, but in newer releases, they added RBAC by default. So you have to also add a user to be able to log in. To start a dashboard, it's still the same. Although the URL is a little bit updated, but it's still a kubectl apply. So I'm going to do that first. And this is going to create the dashboard. Then I'm going to create a sample user. This is a user that I'm going to add to the account. This is a service account. It's called admin user. And this is a cluster role binding to bind to this user, this admin user, to bind a certain role. And the role I'm going to add is cluster admin. So we're going to add a user that will be admin, a user that will be able to do everything. I'm going to create this new user. This new user is created. Now that this user is created, I can retrieve a token. So if I do kubectl in the kube system namespace get secret, and I'm going to filter on admin user. then I will see here I have admin user token and then this random string. And if I describe this secret, then I can see the secret. Using this token, we can now log into the cluster without using our certificates. So by default in Kops, we are using certificates to log in. Those certificates are configured here in kubeconfig. So rather than using those certificates, we're going to use a token. And then the last thing that we need is the password. So we do kubectl config view, or we just open the editor and edit the config again. Then we see the admin login and password that we need to log into the API server. So we're going to log into the API server, enter admin and then password, and then use this token to log in. So let's try that out. So this is the first login. I'm going to enter admin and my password to log in as an admin. And now I am logged into the API server. To access the UI, I just type /UI, and then I will be redirected to the UI, to the Kubernetes dashboard. Two ways to log in, using kubeconfig or using a token. Even if you use kubeconfig, you still need to have your token configured in the config, so it's easier to just copy paste this token here. From here, we can copy paste the token that we need to log into the dashboard. Going to enter this token, click sign in, and then I'm logged in to the dashboard. Here you have an overview of what I am running right now in my cluster. So you can just go a little bit around, click on the links here to see what is running on your cluster. In the next demo, I will show you the same with Minikube, and then I will also go over some dashboard items. In this demo, I'm going to walk you through the WebUI. If you're using Minikube dashboard URL gives you the correct URL that you need to access the dashboard. If you are on AWS, you can use the commands from the theory to launch your dashboard. In the end, you should both see something like this. This is the Kubernetes WebUI. Here we can do exactly the same as with our command utility, kubectl or kubecontrol. We can get information from the namespaces. This divides the cluster in multiple namespaces. We have the default namespace, that's where we have been deploying our apps in. We have one node here, Minikube, the labels, it is ready and it's already ready for 4 days. The allocated resources, so here you find some useful metrics. We have 2 GB of memory approximately. We have 4 of 110 pods running. It's a boot to Docker image. So we can say, we can go to deployments, for instance. We have deployments, replica sets, replication controllers. Most of these things we've already seen. Pods as well. And then the other ones I'm going to cover in the advanced section. And we have services, ingress, volumes. I'm going to cover later. Persistent volumes, I'm also going to cover later. Secrets we've already covered. And then cosmic maps is going to be very soon. Deployments, we can just click this create button and you could create a deployment right here. You can specify these app details here, or you can upload a YAML or a JSON file. Rather than using YAML files, you can also use JSON files. It's just a syntax difference. So let's say that I start our hello world deployment. Then if I click on deployments, you see our deployment is now running. It has a label. Well, it is actually spinning up right now. It's not running yet, but now it is running 3 out of 3 pods. And we could just delete it from here again. So we can do the actions here. We also have the details here. It's just a dashboard. You can do exactly the same things as with kubecontrol. So if you don't really like the kubecontrol tool and you rather have a UI, you're free to use this one rather than the kubecontrol. I will continue with kubecontrol in the next lectures.